Welcome to week 5 of Statistics in Medicine. You've made it through 2 of the hardest weeks of this course. The material on probability and probability distributions was quite challenging. This week's material builds on those concepts, but you'll be happy to know that there are a lot fewer calculations. In fact, this week and next week are quite conceptual. This week we're going to get to the heart of statistics. We're going to talk about the idea of statistical inference. So statistical inference is the idea of confidence intervals and p-values. And what I want you to come out of this week with is a deep understanding of conceptually what is a confidence interval and what is a p-value. 2 teasers for this week. So first of all, probably all of you have been reading polls, reading about polls all your life. People love polls. They're very interesting. So here's an example of a poll I dug out from 2012. It was a New York Times CBS News poll. They found that 59% of those surveyed said that health insurance plans of religiously affiliated employers should cover the cost of birth control. And this has been a controversy in the U.S. Some religiously affiliated employers who are affiliated with religions that maybe oppose birth control have had an issue with paying for birth control. And the majority of U.S. citizens appear to actually think that they should cover the cost. Now, you get to the end of this article in the New York Times about this particular poll, and you read something that you read every time you see a poll. It says, the nationwide telephone poll included 1,064 registered U.S. voters. The margin of sampling error is plus or minus 3 percentage points. So every time you read a poll, you get at the end, they throw out this margin of error. And we all kind of roughly understand what's meant by a margin of error. It's capturing the uncertainty in the poll, but where exactly did that margin of error come from, and what exactly does it mean? So after this week, you will know exactly where that margin of error came from and exactly what it means. The second teaser for this week harkens back to the promo video for this course. I introduced in the promo video an example about an HIV vaccine trial that occurred in 2009. So there was an HIV vaccine trial in Thailand, randomized about 8,000 people to an experimental vaccine and about 8,000 to a placebo. And that trial generated a lot of headlines because in the results of that study, they actually saw fewer infections in the vaccine group, 51 in the vaccine group versus 74 in the placebo group in one of the analyses they did. And that difference turned out to be statistically significant. That generated a lot of excitement because it was the only vaccine trial that's shown any potential efficacy of an HIV vaccine. All the other trials have been completely negative. Some have even shown that the vaccine seemed to increase the risk of infections, if anything. So this generated a lot of excitement. However, there was also a lot of controversy over this trial, and there was a lot of public discussion about the topic of p-values because p-values played an important part in the results of this trial. So we're going to return to this example in the very last module of this week, and I'm going to talk about that trial and what the p-values from that trial mean and how do we interpret the results of that trial.